Hello, my name's Clarissa. I'm Associate Director at Total Home Environment. We design, supply and install heat recovery ventilation, heat pump ventilation, air source heat pumps, compact service units and central vacuum systems. We're also MCS certified, which means that we can help you claim back with the RHI or the Green Homes Grant. Today I'm just going to be talking about preparing for the design and installation of your heat recovery ventilation or heat pump ventilation system. So here we've got a ventilation unit with heat recovery, and it's located in the loft area, and basically it's got two fans in it. One draws fresh air from outside and the other takes stale air out of kitchens and bathrooms. The two airflows cross each other in a heat recovery matrix. They don't mix. But the stale air gives up its heat and gets chucked outside, and then that fresh air that's now been nicely warmed gets put into the habitable rooms of your house, like bedrooms and living rooms. And it means you get a whole house air change every couple of hours, and you recover about 90% of the heat that you would otherwise lose through trickle vents, extractor fans and other forms of ventilation. But you can go a step further with heat pump ventilation. Same concept, except that it's also got an integral micro heat pump inside it to provide a little bit more heat to the air going into your supply rooms. So if you're really well insulating your house and making it airtight, you might not actually need a formal heating system. You can add on to it heated ceiling terminals to add even more heat to a particular room or zone, and they're very energy efficient. The beauty of this system is that it can be reversed to provide cooling. Now, it's not like air conditioning, but you will feel a difference of between 4 and 5 degrees, which could be the difference of a good night's sleep or not. Another part of the system is something called HPW. That's heat pump with a water cylinder. So basically it's a 300-litre water cylinder with a heat pump on top of it, and that supplies all your domestic hot water, the water that comes out of your taps. Also, it has a secondary coil, so it can supply heat to a little bit of underfloor heating. So it can form the basis of your ventilation, heating, space cooling and hot water all in one system without any hassle of having to bring any other items onto site. Now, with regards to ventilation units itself, they can be ceiling mounted, they could be floor mounted, so they'll be a bit like the sort of size of a kitchen unit with the ductworks coming up, or they can be horizontally mounted on a wall. That unit at the bottom right hand corner, that red one, that's a compact service unit. That's basically a heat recovery ventilation unit with a heat pump in it for space heating and cooling on top of a small 220-litre tank. So it's good for apartments and flats and does everything in one unit. So things to look out for within units, a good quality unit. Make sure it's got F7 pollen filters. That will protect the unit that much more for wear and tear, and also it's great for asthma and allergy sufferers. If the unit's got a really good heat recovery matrix within it, very efficient one, you want to make sure that it's well insulated, not just 10 mil of insulation around the unit, otherwise all that heat is going to be let out. Make sure that the fans are EC fans, electronically computated, so they use the least amount of power. Also make sure that the bypass is an automatic summer bypass. This doesn't recover heat during the hotter months, and you know what it's like with the English weather. 1 minute it's 30 degrees, the next minute it's 10, and you don't want to have to actually slot something in each time to stop it recovering heat. So make sure that the bypass is an automatic one. Make sure that it's certified SAP Appendix Q, so it will go through building regulations. And obviously, if you want that extra heating and cooling, obviously go for one that's got a heat pump inside it. Controllability. You can have the most energy efficient unit on the market, but if you can't control it, it's not going to be that efficient. So here you can see a controller that allows you to program exactly the target temperature that you want the unit to get to. You've also got an information panel, so you can see what the temperature is outside, what you're supplying into, etc., into the rooms. And also, probably the most important thing is the reminder to check your filter. 3 or 6 months can come round very quickly, and if that unit is having to struggle to suck through air through a dirty filter, that's more wear and tear, and obviously it's not going to be doing as good a job. Seeing the fan speed is quite handy because each day you're not on the same sort of airflow. So being able to have a 24/7 timer where you can program in exact airflows. So for instance, it will be at 25% during the night, 50% during the day, and 75% perhaps when you're cooking or showering. And also being able to boost the fan speed at any time, perhaps when you're having a party or something like that, and not having to remember to turn it back down, because you can sometimes forget, and having one that will automatically go back to whatever your 24/7 program is programmed to at that point is very useful. Then if you've got extra heating through a duct heater or with the heat pump ventilation system, then it's obviously good to have control of that. So unit location, things to think about. Don't just go from what the specification sheet gives you with regards to dimensions, because you will have ducting and silencers that come off it. And if you go for the HPW, then you will have an underfloor heating module possibly as well. The unit's going to be taking moisture out of the air, so it does need a condensate, which your plumber will need to connect to the house plumbing system. Filter-wise, those filters are going to be as deep as the unit, so you need to have that space in front of the unit as well. Insulation, some of the ductwork is going to be insulated, so that could bulk the system up slightly. Obviously the units are going to have to be plugged in, so your electrician's got to provide some fuse spurs, and if you're going to go for heat pump ventilation, then you'll have controller and electricity going to those heated ceiling terminals too. So obviously, please get a plant room designed into your plans. Everything can go in there then, your central vacuum unit, your ventilation, any water cylinders, PV batteries, electricity meter. It's really good to have one place to put all that sort of thing. But just watch it, if it's in a basement, you do need to get your ducts above ground level so they're out the way of leaves and the snow line. Failing that, a utility room, perhaps you can have still have washing machines, etc. underneath the unit if it's mounted on the wall, and a cupboard. Just make sure that the doorway is wide enough so that you can actually get those filters out to change or clean them. Now if it has to be up in a loft area or something like that, you can utilise the eaves space, and you can see here on these plans that we've actually been able to hide the ductwork in that small sort of triangle of space within the eaves. Now, if it does go into a roof space, if you can possibly make sure that your roof is a warm roof, as in the insulation is up in the rafters rather than down here, that will be termed a cold roof space. You can see in the cold roof space we've had to insulate the ductwork quite a bit more, which does add to your quote. You could have it in an integral garage, but it is a fire compartment, so whenever ductwork actually goes through into the house, it does have to have a fire collar. Again, that could increase your quotes. Here you can see units in situ, in a loft, attic, a cupboard, even in a bathroom and conservatory here. So ducting, we would always specify rigid metal safe seal ducting. It's crush proof, it's naturally antibacterial, no mice can bite through it, airflows on paper actually happen in practice, and there's absolutely no off-gassing, which is very important if you're going to go for the heat pump ventilation where extra heat is going to be formed. Occasionally we would use flat channel, but only when we're having to go underneath a steel. Semi-rigid metal, I would never go for it, because if somebody by mistake treads on it and you can't see it, then that's airflow gone forever, and it might not even be SAP Appendix Q certified. And flexible, don't touch it, it won't get through building regulations. And if you get a quote that's too good to be true, then just check what the ducting specification is. Radial is quite good. It's got a smaller bore, so it's quite useful if you can't get the bigger 100 or 125 mm ducting around the house. But because of that, you might need a couple more ducts going to a particular room rather than just one. It also has to have a manifold for the extract and a manifold for the supply, and they can, as you can see by those boxes there, they can be about half the size of the unit again. So radial ducting is good, but it's made out of plastic, so it's mice can eat through it. and although it has got a membrane put in to make it naturally antibacterial, we don't actually know how long that would last. And we certainly wouldn't specify it with heat pump ventilation because of the off-gassing potential. So where does ducting go? Well, normally it will go at the back of fitted wardrobes, airing cupboards, when you have to sort of go up and down the house, back of baths and things like that, but mostly it'll get hidden in the floor. So flooring structure is quite important. Now if you've got a traditional floor because it's a renovation or something, then the ductwork has to run with the joists, it can't cut across them. So you have to be slightly cleverer with where you put ducting. Beam and block is great. Duct goes anywhere, you just have to make sure that the void is wide enough so that the 90-degree bend can turn as well into the ceiling. Webbed or posi joists, you can run across them, so they're brilliant. You just have to watch timings because the ductwork does come in 3-metre lengths, so if you can get it sent to site before the people start putting the webs in, so you can slot them through as they're putting them in, that's great. And just making sure that the webs do line up so that there's no kinks involved. I-beams or engineered beams, these are really good. You just have to check with, or we would have to check with your engineer on how big the holes could be and where those holes could be placed. Terminals, these usually go in the ceiling, but if you've got vaulted ceilings, then they would go in the wall. We just have to watch where the heights are, because if it's in an extract situation, we want it to be very close to the ceiling to capture all that heat. But conversely, if you're supplying you don't want it to be higher up than 2.4 metres, otherwise you're just not going to feel the benefits. If you're having heated ceiling terminals, this is what they look like, and they're self-regulating, so it means they only use the electricity required for the exact heat. It's not like a kettle where 1.4 kilowatts is being used, whether the water inside the kettle is hot or cold. Then you've got the controllers. These are usually, the main controller is usually located in a hallway and away from heat sources or sun, because they do have sensors going on them. If you're having a heated ceiling terminal, then you'll also get a room or zone controller as well in those supply rooms. And if you're having a carbon dioxide or humidity sensor in a master bedroom or a bath or shower room, that's where those will be. Some of the units, some of the ventilation systems will have a mobile app as well for remote diagnostics or on-the-go control. Breakout points, usually this is in a roof or an external wall. This is where the unit sucks air in and pushes air out. We would just have to check about house orientation and any prevailing winds. Best practice is that in and outtake are at least 3 metres apart or 1 metre vertically. And we would try and keep that fresh air intake away from soil vent pipes. So information that is required from you to establish what type of ventilation system is best for you and your home. Well, getting that room by room heat loss calculation done so that we know what your heat loss is to start off with. That's the sort of information that we're going to need with regards to whether you're building in SIPs or ICF, what your U values are going to be. We need drawings and sections to work out the volume and area and what your air tightness target will be. That's something your architect can help out with. And whether you're going to have any wood burning stoves or heated towel radiators, that sort of thing. Now this is the biggest system in your home, so please do plan early for it. Talk to us early and budget for your materials. Anything between £2,500 and £7,000 for a good heat recovery ventilation system, and anything between £14,000 and £30,000 for a heat pump ventilation system that's going to be doing your heating, your cooling, your ventilation and your domestic hot water. Installation wise, if you're not going to do it yourself, that's the sort of figures that you're going to be thinking about. Timings on your Gantt chart, anything up to 3 weeks for first fix, up to a week for second, and up to 3 days for commissioning. Do talk to your other trades early. Your electrician needs to know, but he doesn't need to quote for extractor fans, but he does need fuse spurs and any electrical requirements for HPV for the heated ceiling terminals. Plumber needs to be aware about that condensate. Window manufacturer don't need to quote for those expensive trickle vents, and your joiner needs to make sure that there's a 10mm gap underneath the door to allow a through flow of air. Now I think that about wraps it up. If you need to talk to us in person and see the units working, then do turn up to our stand TV 58, that's along Expert Alley. Or if you want to see live demonstrations, we've got one at the Pot and Passive House in St Neots, in our showrooms in Morton in Marsh, or at the Build It Education House at Graven Hill in Bicester. Thank you for listening.